Bismillahirrahmanirrahim. Good evening, everyone. Today our lecture will talking about the dependent sources circuits analysis, and we will know how much types we have belong to this topic. Honestly, this topic is very big. It's huge, actually. By my searching, I selected some important questions to can draw some picture, or you can say some diagram, illustrate to us this topic talking about what. Let's go from the first question. What is the dependent sources circuits analysis? Dependent sources is, like we know, is depending on two important elements, current or voltage, sources whose value is not fixed. What does mean is not fixed? It's not fixed, that's mean independent. Here we will dealing with two types of sources. Independent, that's mean has a natural number. And this number will not depend on any another element. But at another hand, dependent source, what does mean? That's mean this source, this number source depend on another element. If this element will change, actually this current or voltage will change. But rather, which depends on some other circuits, current or voltage, the general form for the value of a dependent source, y equal kx, and ky is current or voltage. But here we have a constant element. This element is k, is proportionality factor. If we're dealing with current or voltage, k result will be at the same because it's constant. Here, how do you solve dependent source in circuit? Sure, when we decided to solve any question, any math question or physics question, we must have something like map or plan. Our plan here will have four important points. Let's know what all of these. Actually, number one, identify all nodes in the circle. Identify all nodes in the circle, in the circuit, sorry, call the number of nodes. What does mean here? This node, and this another node, number two, number three, number four, five, six. That's mean here we have 6 nodes. This is very important to us. And after that, we will see to the current side, something like that. Let's know that one by one. Select a reference node. 3, assign a variable of each node whose voltage is unknown. What does mean for what is the unknown element here? For example, 3ix. Here we're dealing with dependent current source. Here we have one unknown element. If there are dependent sources like this, here dependent voltage sources, dependent ampere current sources, but here independent voltage source, independent current source. Here we must focus at first at the not diagram, this circuit map, and at first we will dealing with the node, and we will select a reference, and after that we will focus on the unknown element. And the last thing will be we will see to the dependent source, and where will be the independent sources. Here, let's close this. Why are dependent sources used in circuit analysis? Sure, this this thing has some benefits, because that is very important to us and we use it. Let's know why. Dependent sources are used to model transistor. It's very important to transistor and amplifier. Let's know how. Dependent sources are used to model transistors and the operational amplifier. It drives the output, something like a driver. Take the current in the copper wire and driver the output side of the circuit, the output side. Dependent sources are usually associated with components or devices requiring power to operate correctly. This is important. What are different types of dependent sources? Actually, we have 4 types, or we can say 2 types, and every one from them has 2 another kinds. Let's start with voltage. Here will be V at the both of them. Voltage, controlled voltage source. The next one, voltage controlled current source. Current controlled voltage source. Current controlled but current source. Here, this is more important to us here. Dependent volt source, independent volt source, independent current source, dependent voltage source. Here, independent current source, independent current source, independent current source, independent voltage source, VCCS. Here we will take simple idea about just about just 2 elements from these 4 elements or types. What is VCVC? What does mean? Voltage controlled voltage source. It is one of the dependent voltage sources. And it voltage sources VC, where the voltage is controlled by a voltage elsewhere. Elsewhere, that means another place in a circuit. There is no feedback between controlling side and control side of the circuits. These important points in the VCVS, and like I said before, it's belong to dependent voltage sources. Let's take this CCCS, that's mean current controlled current source. A current controlled current source has a current equal to some other current elsewhere in another point, in another place, in the circuit multiplied by a given. What is the another name? That's mean, let me say, it's not has just one name. We can use another name. This name is controlled sources, not just dependent or independent sources. We can say controlled sources. Like I said, dependent sources are also known as controlled sources, as they are controlled by other elements present in the circuits. What is the difference between voltage source and current sources? Just selected this question from Google because I think it's an intrinsic question. Not difficult, but important to us to know what the difference between all of them. A voltage source has forcing function of a voltage. Current source has a forcing function of current. The first one, forcing function of voltage. The second one, the current source has a forcing function of current. Like we see, like I said before, we have 2 types, and all of them has 2 types: voltage sources, ideal voltage sources, practical voltage sources, and the same thing with the current, ideal current sources and practical current sources. What is the difference between voltage sources and current sources? Is voltage dependent on current? Let's delete this question and This, I think this question is enough. Is voltage dependent on current? Yes. Actually, the voltage and current have a strong relation between them. If we do some change in the voltage, we will see the same thing. Not actually the same thing, but the current result will change. Let's know how. And the amount of current in a circuit depends on the amount of voltage, and the amount of resistance in the circuit to opposite current flow. This that means the resistance here is very important, and we have relation between the current and voltage. If we change one, the other will change, and the resistance is very important. Why? In the circuit, to oppose the current flow. Or like I said before at the last lectures, we use the resistance to protect our devices from current bag or leaking current. For this reason, the quantities of voltage and resistance are often stated as being between or across, because that, and like I said before, we used it to protect our devices, and always we will put the resistance between or across 2 points in a circuit. We depending totally on the Ohm's law. You know Ohm's law, voltage equal current times resistance. Here, that will be between or across 2 points in the circuits. After that, let's take some examples of the voltage sources like nuclear, coal, natural gas, hydroelectric, wind power, and let's say all of these to generate voltage. What is voltage controlled current source? In a voltage controlled current source, we mean VCCS, a small amount of voltage across the input will proportionally control the current flow across the output. That means some relation between the input and output. Here, this amount of voltage across the input, will proportionally control. We will manage, we will do some checkpoint on the current in the output. This type of circuit is commonly used in electrons to drive current control devices. What is the ideal voltage sources? Why any current in any direction could possibly flow through the sources? Some relation between these two questions, because the answer will be one to all of them. An ideal voltage sources is a two-terminal, like a battery, like any normal battery, two-terminal element with a property. I say battery because the battery has two elements. That's not something like condition. I didn't mean positively charged or negatively charged or something like that, but has two terminal element with the property that the voltage across the terminals is specified at very instant in time. The voltage doesn't depend on current through the source. That's mean here we have a special condition when we dealing with ideal voltage, because the voltage here doesn't dependent on the current through the source. Why? Because this feature, because this condition, any current we can answer this question, because that any current in any direction could possibly through the source. Why? Because here we're dealing with a special condition here. The voltage doesn't depend on current like the Ohm law and other normal conditions. But this dealing with one condition inside the source. What is the difference between independent source and dependent source? Dependent source based on the voltage over a resistor, like Ohm law. This were this independent sources based on the voltage divided on the resistance, or even the current flow through a given wire. But independent sources introduce current divided on voltage, not voltage divided on resistance like the dependent sources. In the independent sources, the situation is different because the relation will act current divided on voltage at particular rate. Here, this the last slide. I depend on this on the source. Actually, I just take the example, solved example, honestly, and try to solve it again because the author didn't use the long details, just use the general function, and after that, the result. Let's go directly to my notes, new share, yes. That's it. Here at 2.3, we have electric circuits. Actually, I changed some elements or some names. For example, here at the source, I sub X. But because some relation between this current and R1, because that I write it IR1, sub IR1. Let's go directly to solve this example. Here, the independent voltage source equal 1 volt. The resistance number 1 equal 2 ohm. Here, independent current source, and the resistance number 2 equal 4 ohm. And here gamma equal 5. All of this information, I take it from the book from the author. After that, we will depend on the total current equation will equal IAC. That's mean I has relation with R or with resistance number 2 between two nodes, A to this side to C. That's mean I R2 equal, or you can say IR1 like you want, equal from Ohm's law, V equal IR. That's mean here I will equal V divided on R. Here we're dealing with VAC divided on R2, 4. And what does mean? That means VA minus V4, because this current between two different potential points, A and C, because that VAC divided on R equal VA minus VC divided on R. Be note, and here, like I said before, we must select the nodes after do anything. Here we have 3 nodes, A, B, A, C, and B. We have 2 resistance. We have 2 different kinds of source. And what the unknown element? The unknown element here is alpha I sub R1. What does mean? To can know how much amperes we have in this within this dependent current source, we must at first calculate IR1. Let's keep going. B node, let us be reference node. After that, what will happen? That means VC will equal 0 because B node will be the reference node. B will be reference node. After that, VC equals 0. Here, VB From this node, the current go directly to independent voltage source. That's mean here VB will equal V source. That's mean VB will equal 1. IAC here, IAC will equal VAC, and VC equals 0 because B will be reference point, reference node. That's mean equal IAC equal VA divided on R2 divided on, that's mean divided on 4 ohm. Now, let's keep going. VB, the voltage source, equal 1 volt. IAC equal VA divided on 4. Here we have two unknown elements, VAC and VA. Let's keep going. What we have? We have the total current equation. Let's know what that means. That means here will be summation current equal IAC, the first one. After that, minus alpha IR1 plus IX. IX, or we can say I sub R1. This. The author used these letters, IX, but I prefer to use IR1. That will be clear here to me. Let's keep going. Now, instead, VAC, we can write VA divided on R. To calculate the result of IX, it's a very important element to us because without it, we can't calculate the alpha IR1. From Ohm's law, V equal IR, TR1. What does mean here? TR1 between 2 points and the current here between 2 different potential points. That's mean VR1 equal VA minus VB, or V, yes, that's right, VA minus VB divided on R1 equal to ohm. Let's try to calculate it. R1, that's mean VB, like I said before, equal 1V. That's mean VA minus VB divided on R equal VA minus 1 divided on 2. What does mean here? We have two unknown elements, IR1 and VA. Here, after that, honestly, I couldn't understand from where the author could use VA equal A divided on 7, maybe calculated by using some equation, but I couldn't understand from where, or the author gave it like the alpha equal 5. After that, we can calculate all of them to come find the result. IR1 equal 1 divided on 14 ampere. What does mean? Alpha R1, the independent current source equal 5 divided on 14 ampere. And after that, another important element was VA to R2 equal here, I'm sorry, here IR2, or I write it the I at R2 equal, let's come back to I at R2 equal AC. Here, let's take a look. I at R2 VAB minus, no, that's wrong, VAC equal VA minus VC, and like we said before, VC equals 0, because that will stay like VA divided on R2. VA equal 8 divided on 7, and at the same time R2 was 4 ohm. That means we could calculate the current at the resistance number 2 equal 4 divided on 7 ampere. That's it. Our lecture is done. Thank you for your listening, your patience. That's it.